In this video, we will learn how to make predictions from the least squares regression line. The Cadet is a popular model of sport utility vehicle known for its relatively high resale value. The bivariate data given below were taken from a sample of 15 cadets, each bought new 2 years ago, and each sold used within the past month. For each cadet in the sample, we have listed both the mileage X in thousands of miles that the cadet had on its odometer at the time it was sold used, and the price Y in thousands of dollars at which the cadet was sold used. With the aim of predicting the used selling price from the number of miles driven, we might examine the least squares regression line y hat equals 40 and 69/100th minus 45/100th times x. This line is shown in the scatter plot in figure 1. So as you can see, we have data provided to us. There are 15 bivariate data elements provided to us for each of the 15 cars. Miles are represented by variable X, and selling price in thousands of dollars is represented by variable Y. Let's use our scatter plot and the least squares regression line provided to us in the visual form and in the equation form to answer the following 4 questions. Fill in the blank. For these data, mileages that are less than the mean of the mileages tend to be paired with used selling prices that are either less than or greater than the mean of the used selling prices. So we need to choose the right option here. First of all, I would like to point out that within the statement, we have some reference to mean mileage and mean used selling price. Although we're not given that ordered pair explicitly, it's not provided to us, we can find it by using the data provided to us in the table. I can compute X bar and Y bar, that's not a problem. But it's not really necessary. I can estimate where it is. I know that ordered pair, and I'm referencing right now ordered pair X bar, Y bar, or mean mileage, comma, mean used sale price. That point will be somewhere on the least squares regression line, and since it's a representative of all X and Y values here, it will be somewhere in the center, roughly. Of course, the data could be slightly skewed here and there, but I can only guess. Say my point containing these 2 coordinates will be there. For example, if this is my X bar and Y bar, I am saying if I pick mileages that are less than X bar, which means on the left side somewhere here. So if I pick mileage like 15 miles or 20 miles or 22 miles, 23 miles, something like that, will they be paired with used selling prices that are greater than or less than the used selling price, the mean used selling price? Well, as you can see, because my slope is negative, my line is decreasing, I have higher Y values paired with lower X values, and vice versa. I have lower Y values paired with higher X values because slope is negative and line is declining, going down. Slope is like I'm going down the hill. All right, that tells me that my answer will be the following. For these data, mileages that are less than the mean of the mileages, or my X values are smaller, they tend to be paired with Y values that are higher. So I'm going to say greater than for this one. Part 2. Fill in the blank. According to the regression equation, for an increase in 1,000 miles in cadet mileage, there is a corresponding either increase or decrease of $4,500 in the used selling price. So let's take a look at this part too. So we have to look at the slope. As you can see, slope right here is negative 45 hundredths. So b sub 1 is 45 hundredths, of course, negative. That negative slope tells me, and by the way, I can write it as a fraction to reflect the rise over run option. In this case, my rise is negative for every positive run. What does it really mean? I hope you still remember from our prerequisite lessons that it means in the numerator we have change in y. In our case, in its dollar amount, over change in x. In our case here, it's the mileage. So in the context of the story, for every 1,000 miles of change, which is our denominator right here, there is a decrease because of a negative sign of 45 hundredths of $1,000. So our answer here is decrease. And it's simply because the slope is negative. Part 3. What was the observed used selling price in thousands of dollars when the mileage was 24.4 thousand miles? My job is to find in our table the observation of 24.4 thousand miles. So look in the mileage column, find 24.4, and find the corresponding observed used selling price, which is 30.4. That's all we need for this one, and it's already in thousands of dollars, so there's no need to add those zeros. It already says it's in thousands of dollars. Okay, last part. From the regression equation, what is the predicted used selling price in thousands of dollars when the mileage is 24.4 thousand miles? We need to round answer to at least one decimal place. So for part 4, I'm going to use my least squares regression line equation to find what y hat value is when x is 24.4. So when x is equal to 24.4, what is my y hat? Y hat happens to be negative 45 hundredths multiplied by the x value which I input into my equation of 24.4, followed by the y-intercept of 40 and 69 hundredths. Please enter this information into your calculator, and when you round it to one decimal place, your y hat in this case should come out to be 29 and 7/10. So it means that when the mileage on that particular car is at 24,400 miles, the price at which it will sell is expected to be at $29,700. Therefore, the solution to the first part is greater than, second part decrease, third part 30.4, and last one 29.7.